As we contemplate the Sun, we are aware of its enormous power and the energy it emanates throughout our solar system. It is hard to imagine anything capable of surpassing our Sun. Yet, beyond our own star lies a cosmic wonder that makes even the mightiest solar giants seem insignificant in comparison. Betelgeuse, the red supergiant, defies explanation with its enormous diameter, irregular pulsations, and unpredictable behavior. The star is an enigma to scientists who are still studying its power and potential. As they investigate this magnificent star in depth, they have discovered something terrifying. Join us on this journey as we delve into the constellation Orion with the James Webb Space Telescope and explore how its discoveries could change our understanding of this stellar giant and its impact on the cosmos. If you're interested in keeping up to date with news from the universe and beyond, subscribe to our channel. Be sure to like this video and turn on notifications. Though many people are unaware of this, it is possible to spot Betelgeuse in the night sky during the winter months in the Northern Hemisphere. Just look up and focus on the constellations Orion and Canis Major to see this dazzling star. You can easily locate the reddish-orange star that marks the upper left corner of the rectangular shape of Orion. The star is one of the largest and brightest in the night sky, making it difficult to miss. However, if you have looked closely, you will have noticed that it does not remain constant. In fact, it varies in brightness periodically. This peculiarity is no coincidence. Betelgeuse is no ordinary star. Although it may appear to be just one more star in the vast firmament, it is located at a distance of more than 640 light-years from us. At first glance, this figure may not seem impressive, but in reality, it represents an enormous distance. To illustrate, imagine we could travel at the speed of light, which unfortunately we cannot. Even then, it would take us more than 640 years to reach Betelgeuse. In a spacecraft, even using our most advanced technologies, it would take more than 12 million years, far exceeding the entire history of human civilization on Earth. However, the faintness of Betelgeuse is not only due to distance. It is what is known as a pulsating red supergiant, an ancient massive star that undergoes expansions and contractions. During these cycles, its brightness can vary significantly over periods ranging from tens to hundreds of days. Amazingly, Betelgeuse can oscillate in brightness from near magnitude 0.5 to 0 magnitude, making it extremely bright. These changes follow cycles, the shortest being 185 days and the longest 2,335 days. At times, it can become quite faint. In February 2021, it reached a magnitude of plus 1.614, its lowest in a long time. Although still relatively bright, it was clearly fainter than usual. Brightness is not the only standout feature. Betelgeuse is known for its distinctive reddish color due to its cool surface temperature of about 3,500 Kelvin, much lower than our Sun's surface temperature of 5,500 K. This lower temperature means Betelgeuse emits less energy per unit area. So, despite its enormous size, it appears dimmer. Don't be fooled, though. Betelgeuse is about 20 times the mass of our Sun. This is one of the reasons it has been the subject of astronomical studies for centuries. It was a prominent object in the night sky even to ancient astronomers. The Greek astronomer Ptolemy observed it, and its name in Arabic means Orion's armpit. Although little could be known back then, modern telescopes have enabled researchers to study this star in great detail. By analyzing the light it emits, astronomers have determined its size, temperature, and composition. The Hubble Space Telescope has provided detailed images of its surface, revealing intricate patterns of gas and dust. These observations allow researchers to model the star's behavior and predict its future evolution. Betelgeuse has also been studied using the Atacama Large Millimeter/Submillimeter Array, ALMA, in Chile. ALMA has provided high-resolution images revealing an extensive plume of gas extending from the surface. This is believed to be caused by pulsations driven by convection, hot gas rising and cooler gas sinking, creating waves through the star's atmosphere. These waves cause the star to expand and contract. Thanks to Hubble, researchers have captured more detailed views of these surface features, including star spots, cooler, darker regions caused by strong magnetic activity. Betelgeuse's magnetic field is thought to be thousands of times stronger than the Sun's. This traps gas in magnetic loops, creating massive star spots. These spots can be several times larger than Earth, covering up to 20% of the star's surface, far larger than sunspots on our Sun. As these spots rotate in and out of view, they affect the star's brightness. In Betelgeuse, both the pulsations and the star spots contribute to brightness variation. Surprisingly, Betelgeuse is not unique. Other red supergiants, like Antares in the constellation Scorpius, also exhibit variable brightness. Antares is about 12 times the mass of the Sun and 700 times its radius, also a colossal star. Red supergiants like Betelgeuse are massive stars near the end of their lives. It's widely believed that such stars explode in violent supernovae, briefly outshining entire galaxies. The unusual dimming events of late 2019 and early 2020 sparked speculation that a supernova was imminent. But further studies revealed that the dimming was caused not by an impending explosion, but by a huge dust cloud ejected from the star. Still, this was a groundbreaking finding. It helped astronomers better understand how massive stars shed material before they die. First, don't worry. At roughly 640 to 700 light-years away, its explosion poses no threat to Earth. But it would be dazzling. Scientists believe the supernova would be visible in daylight for weeks, possibly months. At night, it would outshine the full moon. The remnant, what's left behind, would be visible for centuries. What remains after such an explosion depends on the core's mass. If it's below a certain limit, it becomes a neutron star, a city-sized object more massive than the Sun. If it's above that limit, it forms a black hole, warping spacetime and devouring everything nearby. For Betelgeuse, either outcome is possible. Multiple observatories, both ground-based and space-based, continuously monitor the star. Hubble, ALMA, the James Webb Space Telescope, and the Very Large Telescope, VLT, all collect data on its brightness, spectral behavior, and surrounding gas. Combined, these observations paint a clearer picture of Betelgeuse's current state and possible fate. While other red supergiants like Antares or Mu Cephei are also massive and intriguing, Betelgeuse is one of the closest and best studied. It's not only massive, but wildly unstable, exhibiting unpredictable variability, dust activity, and surface features. If placed at the center of our solar system, it would engulf everything out to Jupiter's orbit. And yet, despite its grandeur, it remains a faint, flickering ember in our night sky, mysterious and powerful, still cloaked in cosmic mystery.